All right, 16, we've got this with graphing calculator on the grid below, sketch graph of f and g, so calculator. Okay, so I just put these both in on the graphing calculator. Make sure you put multiplication between those two, or else it won't do it, between the x and the arc cosine x, okay? So these are from -1 to 1, so I'm just doing graph trace on both of them. So for the arc cosine one, -1 is at -3.64, so like here. And if this were exam, I would put it on there. For the cosine graph, the cosine 2x, it's -1, -0.4. I'll do it in a different color. So like here. And then the other endpoint is at 1. So that's going to be same thing here. And then for the other one, it's 0.5. So like here. Now let's get the x-intercepts. So of the the cosine function, so that's going to be -0.8 and 0.8. Again, just label these. And then the y-intercept is 1. Okay, so it's looking like you'd expect it to look. Something like that. Okay. Then the arc cosine function, you can see that the x-intercept and y-intercept are 0, okay? And we should just get that maximum there. So we want, so that's 0.8, 0.9 about. 0.8, yeah, whatever, like that. Okay, so that's the graph of f and g. So then, and like I said, put these actual rounded coordinate points on there. Write down the solution of the equation. So that's just the intersection, which is 0.412, 0.679. So since it's a solution, you just want the x value. So 0.412. And then for C, the range of G is the cosine function. So that is going to be from -0.416 to 1. System of equations is given by that. For each equation, express y in terms of x. So we're going to have cosine y equals 1.2 minus cosine x. And then we need to do the cosine inverse of 1.2 minus cosine x. And then the second one, we've got sine y is 1.4 minus sine x. And then we've got inverse sine, like that. Okay, so that's A. And then we have to solve the system for 0 to pi for both x and y. So we're just going to put each of these in on the graph. So finding the intersections, we're going to have, I guess it's a coordinate point. So we're going to have 0.464, 1.26, and that's definitely in between pi. And then we're going to have 1.26, like that. And that's all there is, because everything else is going to be outside pi. And that's the graph of it, okay? Oops. So, 18. We've got this television screen. height of 1 meter is built into the wall. The bottom is 1 meter above the observer's eye level. Okay, so O is the observer's eye level. The angle of elevation from the observer's eye to the top and bottom are alpha, beta radians. Horizontal distance from the observer's eye to the wall is x. The observer's angle of vision is theta. Okay. Show that theta is arctan 2 over x minus arctan 1 over x. So I think we can do the fact that, that alpha minus beta is theta. So alpha is tangent 2. So tangent alpha is 2 opposite 2 over adjacent x. Tangent beta is 1 opposite 1 over x. And then if we solve for alpha, we have to take the tangent inverse of 2 over x, and beta, same thing, tangent inverse of 1 over x. So that means theta is tangent inverse of 2 over x minus tangent inverse of 1 over x. Okay, express theta in that form. Theta equals that. So automatically thinking that we need to do tan theta, because we have to eventually take the arctan after a while. So if we do the tangent of this whole side, that's 1 over x, sorry. 1 over x. Okay. So then this is tangent a plus b, well, a minus b. So this is going to be tangent of a minus tangent of b over 1 plus tangent A, tangent B. Okay, so that's convenient because a lot of those will cancel. So we've got tangent theta still. That's 2 over x. That's 1 over x because those tangents of the tangent inverse. And then we've got 1 minus, so that's going to be 2 over x squared when you multiply the 2 over x times 1 over x. And then that's going to be, all right, so hold on. So that's going to be 1 over x over, and then that's x squared minus 2 over x squared on the denominator. So that's 1 over x times x squared over x squared minus 2. So that will cancel. That's what tangent theta is. So then we've got that theta is arctan x over x squared minus 2. So that a is 1 ax over x squared plus b. B is negative 2. Just looking at the mark scheme, of course, I made a thing. So this needs to be plus here. So sorry. Okay, so find the maximum value of angle theta and the value of x where this max occurs. So with graph and calculate, thankfully. So we're going to put this into the graphing calculator and find the maximum. So you're just like, it's just like y equals basically. So x ends up being 1.41, which is root 2. Don't worry about it if you didn't know it. And then theta rather, is 0.3398. So now for D, find where the observer should stand. So we're looking for X. If you want the angle of vision, which is BOC, to be 15. So we want 15 degrees. We're using this one. Equals tangent inverse 2 over X minus tangent inverse 1 over X. So I would graph this. So you get 2 X's. That is 0.649. And you get 3.08. So those are the two places the observer should stand if you want to get 15 degrees. Okay, function f is this. Sketch the graph. Okay, so we want to sketch this graph from negative pi over 2 to pi over 2. So the first thing we need is graph trace endpoints. So also the first thing that comes up is 0 is undefined. So that's definitely an asymptote. So if we move over on this graph, and put in, so if we do graph trace, negative pi over 2 to find the endpoint. All right, that's -1. So let's just put that there. And then we need pi over 2, because that's the other endpoint, and that's at 1. So here. And then we need x-intercepts. So we're going to have -1.16. So negative pi over 2 here is like -1.5. So let's just say this is, that's -1. So we're going to be, the x-intercept is -1.16. And then the other one is 1.16. So same deal over here. Obviously label these points. And if we graph, let's see, we've got to find the asymptotes here. So if we kind of just push, oh wait, hold on, we need to go to trace, graph trace. And then I think you can just like push over. Oh no, it doesn't work. So the asymptotes. 0 we've already got. If we do, sorry about this, pi over 4 maybe? Yeah, I just guessed really. It's undefined. So at pi over 4, so if this is pi over 2, we need pi over 4, which is like here. And that's coming from the tangent function. So you can see when these are undefined. I guess you have to do it by hand. If you wanted to see when tangent's undefined, that's at pi over 2 and 3 pi over, so tangent's undefined here and here, right? So you're going to have 2x equals pi over 2, or 2x equals negative pi over 2. So that's why it's pi over 4 and negative pi over 4. Okay, so then you've got that this is tending towards that, and this is tending towards that, and I'm going to erase this bit because you shouldn't be outside of your domain. And the last thing is, if we zoom out a bit, because you can't quite see what's going on, we have to find the max and the mins. Oops. Oh my God, I'm so sorry. Maximum. So the maximum is at negative 0.4, negative 3.6. So it's like here. Maybe like here, whatever. Just, and then it's going to tend towards the asymptotes. And then this minimum is here at the opposite. So 0.4, 1, 2, yeah, like up here, whatever. Something like that. Okay? Ew. So x-intercepts, are negative 1.160 and 1.160. And then the asymptotes are at x equals 0, negative pi over 4, and pi over 4. And the coordinates of the max and mins are 0.441, 3.56, and negative 0.441, negative 3.56. Show that the roots satisfy the equation. Okay, so we are going to have, if we just get this in terms of stuff we know, 1 over sine x plus sine 2x over cosine 2x, and we want the root, so it's equal to 0. Okay, so if we do 1 over sine x equals negative sine 2x over cosine 2x, and we want this all in terms of cosine, okay? So we're going to have we're going to have cosine 2x, and if we want in terms of cosine, we have 2 cosine squared x minus 1 equals negative sine x times sine 2x, which is 2 sine x cosine x. So, and this is going to be negative 2 sine squared x cosine x, and this is going to be 1 minus cosine squared times cosine x. Okay, almost there. And that's going to be negative 2 cosine x plus 2 cosine cubed x. So 0 is 2 cosine cubed x minus 2 cosine squared x minus 2 cosine x plus 1, which is what they wanted. Show that f at pi over x, okay, so f at pi over x, minus x. So show that equals to 0. So the function is cosecant. So we're going to have 1 over sine pi minus x plus tangent 2 pi minus x plus 1 over sine pi plus x plus tangent 2 pi plus x. And we want to show this equals to 0. Okay? All right. So, this is sine pi cosine x minus cosine pi sine x plus tangent to theta. So I'm going to do like, this is 2 pi minus 2x. So we're going to have tangent 2 pi minus tangent 2x over 1 plus tan 2 pi tan 2x plus 1 over sine pi sine x, cosine x plus cosine pi sine x plus, and same thing again, 2 pi plus 2x. So that's tangent 2 pi plus tangent 2x over 1 minus tangent 2 pi tangent 2x. Okay, we're going to get rid of a lot of these because of 0. Okay, so sine pi is 0. Tangent 2 pi is also 0. Sine pi, tangent 2 pi. Okay, so we've got, and cosine pi is -1. So this is 1 over sine x. And then minus tangent 2x plus 1 over negative sine x, because cosine pi is -1, plus tangent, oh thank goodness. Okay, this and this cancel, this and this cancel, so 0.